gonna start talking about. Hello everyone. Today we're gonna start talking about tangent lines and derivatives, and then we're gonna solve an exercise that involves both. So to start off, what are tangent lines? So when you have a curve, what you see is you have infinite points in this curve, right? And what you can see in this curve is that in each curve has a tangent line that is attached to it. So here there are infinite tangent lines. Here's one, here's another, here's another. And these tangent lines, they show the slope of the curve at each point. Therefore, in this point, thanks to this tangent line, we can find out what the slope of this point here is. So we call this A. If we find out the tangent line, we can find what the slope of this graph is. Therefore, curves are usually put in this form: y equals x squared plus x plus c. This is what this slope right here would look like. Well, tangent lines are y equals x mx plus n. So what can we see here? What we can see here is that this is to the second degree, to the second power, while this is to the first power. Now, if we use an example, which we will later, you will see that the curve right here is related to the tangent line by one way, and it is through the derivative. Now, in order to do the derivative, it is quite simple, even though at times it can get complicated. So let's say you get a function of the type y equals 3x3 plus 2x minus 3. So for this, what we're going to do, let's choose this. So this is our function. So in order to derive this, what you're going to do is follow two simple steps. And this is in grosso modo, but we can go further in depth in a different video. So for f of x, in order to find the derivative, this is the notation for it. We're going to put this number, the power, we're going to put it down, and we're gonna make it multiply whatever was before, and then we're going to subtract 1. So this would be done this way. So for 3x minus 3, what we do is we get 3, we get the x, this stays the same. Now here we have a 3, what we're going to do is this 3, we're going to put it down, and it's going to multiply the rest. And then this 3 right here that we had before, is going to be subtracted by 1. So we're going to have 3 minus 1, which is equal to 2, okay? So we're going to put 2 directly. So what would we have here? Here we have exactly this. We have 3 times 3, which is 9, times x, times 2, okay? And then here we'll do the same thing. It's the same concept applies. So for 2x, we can imagine that this is to the 1 power. So what we would do is we subtract, we would put down the 1, so it would be 2 times 1x. And then we would subtract 1 to the power, so it would be 1 minus 1, which is 0. So for when a number is to the 0 power, that is equal to 1. Therefore, here we have 2 times 1, and the x to the 0 turns into a 1. Therefore, here we have just 2, since this follows this logic, okay? And for minus 3, what we'll do is just simply when there's a number on its own, we'll consider it a constant, and in that case it just disappears. It doesn't exist for derivatives. So here we need plus r. Okay, so that's a bit the start for how derivatives work. And now we're going to solve an exercise. So the exercise states as follows. Find an equation to the tangent line to the curve y equals 3x squared minus 2 all divided by x at x equals 2. Okay? So here's what we have. We have our function, which is f of x equals 3x squared minus 2 divided by x. And we have to find the tangent line to this at point at x equals 2. So to start off, to find the tangent line, we have to derive this function. So to start off, we have to derive this function. So in order to derive, what we're first going to do is simplify. Because this function can be simplified. And I highly recommend simplifying all of the functions you have, That way it's easier for you to then derive. So one, we're going to simplify. So what we have here is f of x is equal to 3x squared divided by x minus 2 divided by x. So here what we can do is we can get the x out from here. And what we're going to get is 3x minus 2 divided by x. So now from here what we're going to do is we're going to go to step 2, which is derive. So in order to derive this function, what we're going to do is, well, the same step as we did before. So we're going to get the 3 divided by x, 3 times x. And what we're going to do is, here we have to imagine it's to the 1 power. What we do is get down the 1, so it will be 1 times 3. And 1 minus 1, so x to the 0 power is equal to 1. Therefore, we just get a 3. Okay? Then we're going to subtract, and we're going to put this. Now this we have to note it in a different form. So 2 divided by x is the same as 2 times x to the minus 1 power. So in this case, what we're going to do is we're going to do it the same way. So we're going to get the minus 2 down, we'll get the minus 1 down, so minus 1 times minus 2 times x, and then we're going to subtract 1 again. So therefore it will be minus 1 times 2 times x to the minus 2 power. So let's put that down all together. We'll get 2 times minus 1 times x to the minus 2. Okay? Now this is our derivative, we're going to clean it up. So f prime of x is equal to 3 plus 2, because minus and minus is a plus, times x to the minus 2 power. Okay? Now, what do we have to find? Now what we have to find is the tangent line to this curve. So this we're going to do it here. So what we're going to do is tangent at x equals 2. So what we're going to do is we're going to get the derivative and plug x into the function. So it will be equals 3 plus 2x minus 2. So what we're going to do here, this is the notation when you want a particular function at a particular point, is you're going to plug in this 2 at this point. So we just do that, and we get f prime of 2 is equal to 3 plus 2 times. So when a function is to the negative square, it's the same as doing this. Plus 2. Therefore, in the end, we have f prime of 2 equals 3 plus 2 divided by 4, which is equal to 3 1/2. So this would be our function and our slope for the active point. Because this is the slope, imagine this is our graph, it doesn't matter if it's up or down. And imagine this is our tangent line, which touches the point which is x equals 2. So here we have x equals 2. At this point, the slope is 3 1/2. Okay? So there you have it. That's an introduction on derivative tangent lines and how to find tangent lines to a particular curve. And yeah, see you next video.